Here we are in Tier 4, this FrontierMath symposium, with the idea of assembling a benchmark of 50 difficult mathematical problems. And what has been proposed to us is to think of a large language model as an opponent. We want to come up with insidiously difficult problems to oppose and test the capabilities of these entities. But you know, what I've discovered today, already after just 5 or 6 hours, is that we've seen a transformation on the part of the participants. When the participants see and test out the pro version of ChatGPT that has been provided to us, you can see their eyes light up, thinking, it is amazing. This could be really genuinely my co-pilot. So where do I think we're going?
Well, I'm very interested on, let's say, the frontiers of what AI can do and cannot do, and also, in some sense, to understand the models better. You know, what the models can do and how they do what they can do.
Is this epoch AI? No, I am very fascinated by what AI can do in mathematics. I'm a little worried whether it will put us out of work, and I came here to kind of try to find out what's going on, the latest, and to maybe contribute to this big thing.
So I also am a problem writer, and I'm on the editorial board right now for the Putnam mathematical competition. So I'm involved in creating problems, and before there was any AI. And so when they started collecting benchmarks, it was a very natural thing for me to try to create some benchmarks. And then later they invited me for the symposium.
I guess here for many reasons. I'm president of the American Mathematical Society, and I've been interested in a wide variety of issues, but I guess I'm also here out of curiosity as well. We're in this team of, I'm not sure how many people are downstairs, maybe 50 people, all in one team of trying to figure out how to make the most challenging wall obstruction for our new friends to try to conquer, to try to make the toughest test for them to do it, and to make it an appropriate test of, a fair test, but which means as hard as possible. So I see these as entirely cognate. And the kinds of problems this weekend are very different than the kinds of problems I've made of before in other contexts, but that stretches my mind, and I feel like it's been very interesting. And the other people here are heavily people who have not made problems like this before. So I bet we're not doing as good a job as we would if we'd been much more experienced, and maybe we won't do as good a job as people might in 5 years, but this is where the learning, I feel like part of the benefit of this is not just the problems, but the stretching of the minds of the people who are making the problems.
It took several iterations because Elliot wanted the problems not to be guessable, and even though he wasn't sure when he would actually ask me to describe the problem and then how one would solve it. And sometimes he would say, oh, this is maybe too easy, maybe not. And then at some point I came up, I started calibrating myself and what he wants, and then I realized that I can come up with something hard that basically only I know how to do. So there are some things like that. It's just not a very mainstream thing, and of course I had to solve it, so it should be doable. So but eventually I found some case which I could solve, but was out of reach of anyone without having the ideas that it involves. And then we tested it with the AI, with the current AI systems, even if you tell it basically what to do, what papers to look at, whatever, it just has no idea how to proceed.
In order to solve my problem, machine would really need to argue in a way that is not even written in any paper, also maybe understood by some people in the field.
I actually can be confident that a graduate student that works with me probably will take a year of his or her time to figure out an answer. And I think with enough help and, putting a lot of effort, they will probably do it. But yeah, again, I think it will require a lot of putting together pieces here and there, and a lot of creativity, a lot of unusual connections that are not easy to make.
Well, I mean, initially I had a forecast about 1 to 2 years. So now I'm not so sure. So I've spent a lot more time with the ChatGPT Pro version and testing problems for Putnam and so on. And it's not so good at extrapolating, and it's not that clear how well and in what direction it will develop, to be honest. It might take longer than 2 years. I mean, of course, it depends on how the community and OpenAI and all these other companies involved in training models, how they will continue to pursue this and how serious they would be for theoretical math.
I'm hoping that my problem is hard enough to last for sure 5 years, let's say. Let me put it that way. And again, it's not even an open research problem, I would say. I can solve the problem, right? It's a problem that I just consider it hard for a random mathematician. If I give it to other people here, they will probably have a hard time doing it.
I hope forever. No, I'm not that optimistic, actually. I am slowly coming to terms that AI may end up being smarter than every human, right, in every sense. So that may happen, but so far it looks like, okay, so what was very surprising to me is that AI actually spontaneously developed reasoning abilities. All right, that's very depressing and but still okay. So maybe I'm overly optimistic, but I think at least for like 100 years, humans should be able to stay a little bit ahead in some fields. Like mathematics maybe is the last field standing in some sense.
And I also wanted to somewhat ideally be a test of the things that relate to human ingenuity, things that the real test for me is I want when one gets solved to say, wow, to really say, wow, not just to have it brute force and not just have something that really knows literature, but something that makes me think, wow, I would not have expected it to be able to do that. That's the kind of problem I would like. But that's the same thing when you make up a problem for a great final exam problem or a problem for a competition that is particularly beautiful. You want something that leaves people remembering the problem and humming the problem when they leave the room and thinking about it afterwards. That should be the kind of problem that we have here. Well, I've seen the problems, and they are. I think it's interesting because we're playing a new kind of. It's an interesting kind of game where it's clear what the opponent is, and we're on one team, and The AI is on another. We're trying to play the game with imperfect information, and so it's interesting seeing that what the problems are like and how they each reflect the composer's understanding of what the game actually is.
I still think most of the problems that are in tiers 1 through 3 are still too difficult for AI. I think the best test results are something like a quarter of the problems can be solved. So I think the jury is still out on them. The problems that we are writing, I hope the score is 0 for quite some time. Will it be 0 by 2030? I doubt that very much. Will it be 80? Will AI get a B? Maybe not. I think the questions will be very difficult. We're putting a lot of effort into coming up with difficult problems based on what we've learned from the previous tiers. So a couple points I want to make. One, it's very hard to write good problems. Two, some of the problems we're writing, we can barely solve ourselves. And so it's with great anticipation that I hope that the AI entities can't get any of them right. I hope they get a 0.
But these models have some abilities that humans don't. I mean, they have a huge database. They can search very quickly. They can mix and match. They can compute. They can run Python code. They can do all sorts of things that for us it would take some time.
There are definitely traits in AI that I would like to teach my students. So, which is both frustrating, but somehow, liberating at the same time. As intimidating as it is for AI to have access to the literature instantaneously, it also shows students we really need to have some sense of the literature. Without that, we are handicapping ourselves. So as students learning a subject, not necessarily as beginning researchers, but at the very early stages, having some exercise and having some experience with AI reveals the need to know the literature.
It does seem sometimes it does seem surprisingly good. I mean, sometimes it gives the correct answer with the wrong reason, but I have no idea where the answer came from. It's almost like Ramanujan, who was coming up with these identities for huge infinite sums over partitions, and it wasn't even clear how he came up or how it was derived. And sometimes ChatGPT does this as well, and I'm like asking it, can you explain? And then it gives wrong explanation, but somehow the answer is correct. And that part is really scary in some sense.
Things that I would have guessed a few years ago, we would have had an advantage by now. We definitely, things like linguistic thinking don't seem to be places where we have an advantage. And I think advanced mathematical creative thinking is where we currently have an advantage. So the things that are harder to think about for humans in terms of mathematical creativity, coming up with new theories and new ideas, are things that currently seem challenging for AIs right now. And then that's the perfect thing to have benchmarks for, because that's the sort of thing where we want to know when some phase change happens and suddenly certain things become possible.
So one thing that ChatGPT tends to do is give fake references, even if it is allowed to search. I'm not entirely sure when it's on and when it's off, and how to check exactly what it's doing. But sometimes it gives fake references. So for references, I've used Copilot more often. That one can actually find papers and summarize information correctly, at least some superficial extent. But then other features are missing. So, and of course, one should take it with a grain of salt, because if it's searching the web, So there was this joke among programmers. I told you to take it from Stack Overflow. Well, yes, I did, but you should have taken it from the answers, not from the question. So sometimes somebody posts some code saying, "Where's the error in this one?" And I mean, it may not realize that it's getting the wrong thing.
So what are some of the features that AI struggles with? Well, some of the features that AI struggles with that won't come as a surprise are the creative bits, the leaps of faith, which are often called hallucinations to make fun of AI. But make no mistake, as pure mathematicians, when we are at our best, when we make discoveries that seem to be a little bit beyond what's already in the literature, let me make something very clear. We are hallucinating. And from time to time, we're right. I know it's common for us to say, oh, the AI hallucinates. How dare it? And it's like a horrible thing. I actually think it's a good thing. When I study these transcripts of AI trying to solve our difficult math problems, this is what it typically looks like. There could be a couple pages of, oh my God, I can't believe the computer knew this or knew that, or recognized it made a mistake and went back earlier and redid a calculation. I feel like I'm talking to a graduate student. But then maybe a couple pages later, you'll see a couple lines of Chinese. And then a couple of lines later, some words in French, but interspersed with actual formulas. It's searching the literature for what it has recognized before. And I think that's what we actually do when we do research. There's this swimming around in uncertainty, being confused a lot. But then every once in a while, you hallucinate. I wonder if such and such a thing is true. Maybe 9 times out of 10, it was just the dumb question. But even if it was the dumb question, you might figure out, oh, I asked a dumb question, so I never have to go down that path again. You learn something from that. And every once in a while, you hit on a question that you can't rule out as being relevant. And maybe that will lead to a solution.
Let me see, in the optimist scenario, it would reshape math by allowing us to learn more things. Students will have a tutor, for example. That's in a beautiful world. This will help students learn more material and practice more problems, because the AI can provide more interesting problems for practicing, for exams. So, and then when we train mathematicians, the AI can help them summarize the literature and move faster with the research. And for research mathematicians working, it will help them as a great tool. So this is the positive view of the future, right? The negative view of the future is people being dissuaded from studying mathematics, because what's the point? AI can do better than me. And that is the future I don't want to see. I mean, I hope that so that's one of the reasons I came to this meeting, to really be sure that we understand what is the reality of this tool. It's like you buy a car, you want to know how fast it drives, right? Are we buying into this technology without understanding that?
So in the early times, the AI is gonna get better and better, and it will help us probably. So it will do proofs of simple statements, maybe do various calculations, give us examples to lead the way. So all these little things that we spend time on when we do research, those will be easier and faster. So in the short run, it's probably gonna be good. Okay, with one little caveat, because this will also lead people to produce more papers with questionable content, and this will flood the space and journals and everything. So I'm not sure that will be that good. The human aspect in the whole thing is that we still have a big picture in mind that the AI doesn't seem to have. And the human part in the process is going to be the selection, or the editorial part, where We figure out what's valuable, what's not, in what direction to go, which problems to solve, things like that. But in the long run, it is conceivable that the AI will become better than any human at anything. So I have a claim that if the AI actually can do math on the level of a math professor, then it will be able to do anything else that is just intellectual work that doesn't require some kind of dexterity menial work. And then the whole humanity has a problem in some sense, because then suddenly all jobs will disappear. The hope is that others will be created, but I'm not so sure. I'm not that positive it's gonna be all good.
We're probably going to talk about the performance on these problems later this summer, and that'll be a big deal. But perhaps the bigger deal will be the realization for the mathematicians that are here and the colleagues when we all go back to our universities that AI is really meant to be a co-pilot. And will it assist our scientific discovery? Absolutely. Just like a large language model can discover new openings in chess or new strategies in Go, imagine the possibilities when that kind of power is applied to our mathematical problems.
I think what will now probably happen is that you get a certain paper that is kind of done by analogy, and you just ask this question to GPT, and maybe it does it. Right, and then the paper is not very interesting. This haven't been. I think this will arrive. So the work of mathematicians will become kind of more creative, there will be less time spent on routine, because this would be able to delegate it to the machines. Right, and kind of, I think it will become even more exciting.
One thing I feel fairly certain about is that people trained in a pre-AI world will keep doing mathematics in the same way, and that's okay, and they'll still do worthwhile work. But then over time, new people coming into the field will do mathematics differently, and it's not the same, but it's analogous to the advent of LaTeX or the advent of people just growing up programming on their own versus thinking of it as something exotic. There's a whole generation of mathematicians for whom the idea of using a computer was strange. And then there's a whole generation for whom, well, of course, you have an idea, you just, code it, and maybe you don't really think twice about it. And it's not weird or strange, and no one says, oh, what a brand new world it is today. No, you're doing the same kind of thing. You do some sort of enhanced thinking. It's the same way that when people did mathematics and for the first time they did it at a university, or they did it with a book, or they did it with a lecture, or they worked with colleagues on a different continent, or they wrote letters, or these are all these changes have happened in the past, and this is going to be a fantastic new change, and maybe it'll be different this time. But so in the past, they always said it was going to be different, and they were never right.
The way I describe it now is that I don't think I can ask a question that AI can't identify with a particular area of mathematics, because it seems like ChatGPT and others just have at their fingertips the accumulation of human knowledge. And it continues to surprise me at how quickly that seems to be the case. 3 years ago, ChatGPT or all of these large language models would get things wrong that a 5-year-old could get right. And now we're asking questions that a PhD student at our universities wouldn't even know where to start to look.
I always thought that they were just regurgitating, but they developed logic right now. So, and actually the idea is, in retrospect, quite simple, right? If you train them on summarizing things, they just extrapolate the key ideas, right? But how do you train them on being creative? I don't know. I have no idea about human creativity, where it comes from.
And I think the natural language, so ChatGPT was certainly mind-blowing when it happened, because that was, compared to what came before, something really changed. And that shift has not yet happened in my mind in mathematics, but it may happen soon. And so there may be a moment at which I say, I think it's entirely possible there's a moment at which I will say, wow.
Well, I mean, if I see an argument that was not a modification of something that was already there, like something that we would interpret as honestly creative, so without something that is not available in the literature, something completely on its own, like it did in the when I guess when it was training for Go, the AlphaGo. So it was learning from humans and human moves, and then that it was extrapolated. And then at some point, it just figured out a move that nobody would ever do. It's like it was a new move, and it won. It started winning. So if it does something like that in math, we haven't seen any of that yet. But if it does something like that, that would be that would be scary and surprising.
And I think that, and I don't know, I'm not going to predict when that's going to happen, but that should happen soon. But I don't know exactly what it's going to be. Mainly when we told something surprising and cool that came from an AI mathematically that I did not expect it to tell me. Just the same as when a grad student tells me something surprising and cool, and I say, wow, then at some point that changes my perception of how I think of. I think, okay, now they've caught fire. And similarly, I feel like the AI is roughly at that stage. But right now, it's at the stage of a slightly enthusiastic but somewhat confused undergraduate. And so it's ready for the next stage, but it's not gotten there yet.
I don't personally foresee AIs replacing us, but rather augmenting us, or more like, there will be a mathematician. So it's very analogous. I'm old enough, to tell you that I lived in the time there were no pocket calculators, and it was a game changer, right? You suddenly have a pocket calculator, you can do more, but you are kind of driving the whole thing. I mean, you're asking the questions, you're driving and I think this is something similar at a higher scale, right? At a higher, several orders of magnitude more than a pocket calculator. But still, it's an amplification that we are going to be able to have as research mathematicians.
I'm an optimist, so my optimistic outlook is something like this. When the combustion engine was invented, if you were a sharecropper, were you out of work? Well, maybe, but you probably shifted to another field. When the personal computer came out, a lot of industries should have died, but on the contrary, just were reinvented, and usually within a few years ended up being far more productive than we could have possibly imagined. So I think that for students today, it's much harder for people in my age group closer to retirement, but for students today to look for the opportunities that would have been impossible or unforeseen and embrace those. Will productivity go up? Yes. Will certain occupations be unnecessary? Oh, absolutely. And to be aware of that and to be prepared for that is what we should, I think, all be doing.
That's a tough one. So you see, people keep playing chess, for example, right? Even though machines are much better than them. So math may become something like sports chess, because we are also running, even though there are other species faster than us in machine, and cars can go faster than us in bicycles, but we keep running, right? And
So I do suspect if this world comes to pass where we're in this utopian world where AIs do everything and it's the anti-singularity and everyone can do what they want, there will be people doing mathematics because it's the most beautiful thing.
No, you see, math is infinite, right? You can always create some models, some world. So this will stay, right? But then once you've formulated things, I will be able to do to answer your questions, right? But maybe it will transform into actually formulating new models and whatnot. I don't know. It depends. Again, whatever I can think of, kind of ostensibly, I can also learn to do that, right? But it may keep adding levels at the levels of what it does, right? So if math will become creating new models, then maybe I will learn to do that. Then math will may become something like creating models that create new models or whatnot, right?
I mean, I can see the human reactions being negative and creating some really bad things for the future of mathematics. Accessibility is one of them, for sure. I fear about the ability of all humans to have access to the knowledge and to the tools that you can have, right? And with AI, just like we want people to have access to Wi-Fi, you want people to have access to transportation. You don't want this to be in the hands of just one person or two persons, right? That essentially some people have access to these powerful models, but not others. Right?
So for mathematics specifically, the most concerning part is that if at some point AI starts to solve actual open problems, maybe Riemann hypothesis or some other millennium problem without serious human intervention, and that would lead to a collapse of the whole field somehow. I hope that never happens, but it is actual danger.
When you were a student in high school and middle school, probably calculators were banned, right?
Yeah, in middle school, yes. Then I came to America.
So that's the right way to raise children, right? Because if you give them calculators, they never learn to count. Similarly, this AI assistants, there is a danger that if they do everything for us, we never kind of learn to do it ourselves. Even if we do know it in principle, if we don't practice enough, we never develop the skills that are necessary for creative sparks, and then we will have creative sparks, right?
I'm very, very afraid. I'm afraid of the humans hyping or exaggerating the power of AI, number one. I'm super afraid of that. And also, I'm afraid of humans that will believe AI is some kind of God that is not wrong and everything like that. So I think it's just a glorified pocket calculator. This is how I feel right now. Maybe in a few years, I will change my, when ChatGPT takes my job, I will change my opinion. But I'm not fearful of the technology on its own as the technology. I'm really fearful of the way that people will interpret it or use it, right? For example, my undergraduates, I'm very worried about my undergraduates using it and getting wrong things, right? And learning the wrong concepts or learning the wrong answers instead of that I'm afraid of. I'm also afraid of people saying, but ChatGPT said this problem is solved, and it's not true, right? The problem is not really solved. So that's one of the things I'm afraid. I'm afraid of the human interaction with AI rather than AI on its own.
I think there's reason to be concerned about all of that. And Hinton, who won the Nobel Prize for inventing AI, he himself spreads his finances out over 3 separate banks because he's worried about whether we can truly tame computer systems that are becoming somewhat conscious. So returning to what we are doing here today in Frontier Math, we're not just asking questions of these systems. We are studying their responses. We are studying their transcripts.
And right now, if the AI doesn't have good verification, or even just some simple discretion of what should be said and what shouldn't, this can lead to exponential problems and get out of control. That's the first part. And later on, if the AI becomes autonomous, and then we have no idea, I mean, what it's gonna do. I mean, people are excited in the short run, but if you start extrapolating, you will soon realize that a few years from now, who knows? Maybe we can't really imagine. I mean, it's not gonna be Terminator, and it's not gonna be like in the movie Terminator. I mean, it's gonna be something much more benign looking.
Testing, like is happening in this meeting, is important. Like understanding what the understanding has to be there, right? And certainly, I think for example, when the atomic bomb was developed, there was some level of understanding of the process, right? So you cannot not do that. I mean, you have to go to some understanding level and understand the limitations, the powerful, at least estimate it. And I don't want to see development that is just develop, and not have some kind of self-reflection and analysis.
I try. So unfortunately, the problems I cannot solve, the AI also cannot solve so far. So it hasn't been very helpful in that respect, but it is helpful in generating code, testing hypotheses. It can even run that code itself. So more mechanical things it can do, and this is really helpful. So but again, one should be very careful what it's giving you, because it sounds very convincing. It gives you something that looks like an answer, and somewhere in the middle of it, something might be switched and make the whole thing completely wrong.
I do use AI in my research, and I use it in a number of ways. There's some rather boring ways that I use it. It's an assistant to me to make sure that that I haven't made, that AI, ChatGPT helps me with gaps I might have in the literature, right? As much as I read the papers and as much as I think I'm on top of the literature, papers are coming out all the time. Their papers are posted to the archive daily. So AI helps me with the gaps. But increasingly, I'm using AI as a discovery tool. Is there phenomena out there that I'm just not aware of? And that's happening all the time. I wrote a paper last year. It actually won a prize from the National Academy, where in a certain area of mathematics called partition theory, we discovered and then proved infinitely many expressions that detect the primes, not that certain numbers are primes, but literally lists all the primes in order without needing to know how to factorize numbers. And a few years ago, I would have thought that was impossible. And the first hints of those formulas were discovered because a computer said, I think there's this pattern here of detecting primes. And I remember just being floored by that.
I actually have not used AI to give me ideas yet, but I have used AI to summarize text, to write code. It's very convenient. I mean, it's a great tool. I mean, it has, for example, I could say, collect the papers that's on this topic and tell me some kind of summary of what is known about this or that. That's, I think, extremely, saves you a lot of time. It saves you a lot of time. Same with coding, things that I used to do for coding that will take me, I don't know, maybe an hour. I don't have to do them myself anymore. I can just tell them, give me that piece of code, and then I put it on the bigger piece of code that I'm writing. So that is, I think, the examples of great positive use of AI. I mean, I tell my students, if you get stuck and you cannot do the answer, you can ask ChatGPT, just check and see how they go over the logic and try another problem. And so it can actually help you learn. If it's like having a tutor, right? But if you trust it blindly, that's where it goes wrong.
Yes, I'll be now using it a lot.
My parents totally just like use it instead of Google for every question.
No, I've been already using the regular ChatGPT instead of Google lately, but not for math because it was not so good at more sophisticated questions. But they saw me fine. I'll be using it for math, yes. My biggest hope, and I think it's not too far off in time, is that actually all the mathematics will be put in the verified database, this lean database, and when you submit a paper to journal, you need to prove that it was lean verified, right? And then at least it will, of course, remove a lot of work from the referees to verify correctness. Machine will verify that, right? And referees will only say whether it's interesting or not. All right, so I hope this period comes before the work of mathematicians become obsolete because of AI.
Yes, 10.
Maybe 9.
I think that's probably going to be a 7 or an 8. And that's simply because people, again, outside mathematics are more trustful of things that they may not understand, right? That's a little bit my concern here.
9.
I certainly think it will be probably a 5.
Probably, I question the scale, so I'll say 8 plus 3i.
I would say 8.
Well, I don't think math researchers will ever be obsolete because an AI doesn't know how to generate good questions. If that happens, wow, that would be really a profound moment. I do know, and we probably use ChatGPT or Perplexity, and they offer natural questions as follow-ups to a given transcript. That's not what I'm talking about. Asking good questions that drive a theory takes skill. And I think we will always need people who can do that. We don't have many people who can do that. These are generally very special people. So on a scale of 0 to 10, probably 7. I think AI will be very important. Maybe an 8.
5.
We are doing this sometime after the symposium, so we have new information, but there was a Scientific American article and also Financial Times article that came about the FrontierMath Symposium, and in the Scientific American article, it's somehow took a quote from Ken Ono that ChatGPT is as good as a graduate student, as a PhD, as a good PhD student, or something like to that effect. So first of all, this is wrong. So of course, Ken Ono was really amazed that it solved one of the problems that he created. But overall, most of our opinions are not that it's not nearly as good. And I mean, of course, it depends on the graduate student, but certainly the good graduate students are much better than that. And in general, we should be careful with statements like this. AI is not nearly close to solving mathematics, the hard parts of mathematics, and nobody should be making such insinuations. So to the math community, I think we should we should all get involved in what's going on in these benchmarking processes, in steering the AI in the right direction to aid us rather than distort the field in some sense. Because, as I already mentioned, there are many dangers in the whole process. It can be very useful, but it can also be dangerous. And for grad students, even though there may be an AI system which can solve all the simple problems in the textbook or whatever, we should still be able to do this ourselves, because at some point this AI system may not be there, and the less we understand how things work around us, the more vulnerable we are. So we should not just rely on the AI to do things for us. At some point, the electricity will stop. What are you going to do? So,
I think it's important to learn the fundamentals the old-fashioned way, but use AI as a helper only with things that you can do in principle yourself, or with things that are not really related to what you're learning, right? So sometimes you can outsource stuff and use a black box, use it like people used computer for computer experimentation, right? So you can you know what to experiment with, but computer can do it for you faster and with large numbers and so forth. So use AI kind of similarly in some sense, then make it your friend and helper, right? But not an enemy of your development.
The advice would probably be the same, which is do what's interesting, as many interesting things, but go as deeply as possible into it as you can, and have fun doing it. That part does not, I don't think that changes with time, or it's not so far changed with time. We're not in such desperate situations that people should drop doing what they enjoy in order to adapt to a desperate reality.
and then we should all, I think, try to understand how these large language models actually work, what makes them go in certain directions. And this is both for AI safety, but also for general alignment usefulness. So this is still going to require mathematics. So we should continue to learn mathematics. It just maybe the end game is not gonna be what used to be now. Maybe we'll have to solve different types of problems.